Alright, in this video, I'm going to be talking about what does udev do in the context of devices. Udev detects devices. If you plug in a device in your computer while the computer is on, it detects that device. It detects that the device is plugged in and present on your computer. It also works in reverse. If you unplug the device from your computer, udev detects that as well. Udev discovers the device. If you have a device already plugged into your computer, when you turn that computer on, it discovers that device. udev detects the device state change. udev detects the device state. If you plug in an external drive with one partition, udev will detect that the hard drive has one partition. That is udev detecting a device state. udev detects the device state changes. If you plug in an external drive with one partition, udev will detect that the hard drive has one partition. If you were to reformat the hard drive and create two partitions on the drive, it's called a device state change, and udev will also detect that. udev communicates with your software about device events. If I'm on a PDF viewer and I plug in my printer, udev will tell the PDF viewer program that a printer has been connected. Then the PDF program will recognize that a printer has been connected and will then be able to print on to that device that I just plugged in, to the printer that I just plugged in. udev supports dynamic device identification. Every device model has its own unique model identification number, and udev keeps and maintains a database of device model numbers, meaning that udev can recognize a device even when the kernel doesn't. If this happens, you will need to manually download the device drivers yourself. udev supports vendor or brand device identification. udev can also identify a device by vendor or brand through its dynamic device identification database. udev sets up permission for device access. This means that you no longer have to be the root user just to mount a file system or plug in a mouse. It allows non-root users to interact with device files in the dev directory. udev assigns names to devices so you don't have to do it yourself. This makes it easier to manage devices and write software that interacts with them. udev supports persistent device naming, which means that the names of devices in udev don't change, while the previous device managers, they could change and would be listed in the order in which they were plugged into the system. udev provides a constant interface for accessing devices regardless of the underlying hardware, meaning that no matter what kind of hard drive, hardware, or device you attach, they will all behave the same through udev. udev provides dynamic device management. udev automatically creates and removes device nodes as they are added and removed from the system. udev ensures that devices are properly configured and the correct drivers are loaded. So there you go. That is what udev does in the context of devices.